Hello everybody, here we are for a quick tutorial about how to work out the names of ionic compounds when you've been given the formulae. I've given you a list of compounds here on the left hand side, and I think the first thing for you to do is to collect for yourself a copy of your periodic table so you've got it in front of you. The one I have here is rather small, it'll be difficult for you to read. So get that and just pause. Okay, welcome back. So, why is our periodic table so useful here? Well, because it's got the names and the symbols of all the elements, and it can also help us decide what kind of compound we've got, whether our compound is ionic or perhaps covalent. Well, ionic compounds are always made up of metals combined with non-metals. If the compound was covalent, it would be non-metal. So, our periodic table is very useful because there's an imaginary line on here which we can mark here. And anything to the left of this, that's nearly all of the elements you'll notice, is a metal element. Everything to the right is non-metal. And there are a few on the border line which we call metalloid. But we don't need to worry about those for the time being. So, that can help us because if we know whether the compound is made of metal or non-metal, we can figure out whether it's ionic or not. So if we just go down our list of compounds and see if these contain metals or not. Well, we've got the symbol Na here and here. If we look in group 1 of the periodic table, we'll find Na, and it's called sodium. And sodium is on the left-hand side of the periodic table, so it's a metal. Magnesium, over here, that's in group 2 of the periodic table. Mg, that's also a metal. Look at the symbol Al. Al is in group 3 over here, called aluminium, and that's a metal because it's to the left hand side of our line. Fe we'll find over here, that's called iron, and that's a metal, it's actually a transition metal. Mg we figured out already is magnesium, and Ga here, if we look down here, we'll find that Ga is called gallium, and that's a metal as well. So, all of our compounds contain a metal, and if we look at all of the other elements, C and O, I'm sure you're already familiar that that's carbon and oxygen, which are non-metals, and oxygen and hydrogen. Hydrogen is a non-metal despite the fact that it's in the middle there. Br is over here, that's called bromine. S over here, sulfur. Cl over here, chlorine, non-metal. P, phosphorus, and NO, nitrogen and oxygen. So you can see that all of the second parts of our compounds are all non-metals. So indeed we're looking at compounds which are made up of metals and non-metals, so they are indeed ionic. So now we want to have a go at naming these compounds. I'm going to start with the compounds which only contain two elements. So I'm going to start with MgBr2. Well, we've decided already that that contains magnesium, and it also contains the element bromine. But when the bromine is incorporated or made into a compound, we no longer use the INE, we change that to a D. So we end up with magnesium bromine. The next compound, we've decided already that we've got aluminium, as our American cousins would choose to call that aluminum. Aluminium, again, combined with sulfur, but again, because sulfur is in a compound, we now call it sulfide. Next, we've noticed that we've got iron and chlorine. Well, the chlorine becomes chloride. And yet underneath we've got another FeCl compound, so this must also be iron chloride. Well, how do we name those two compounds? Well, if we just pop over to the next page, we know that we've got FeCl2 and FeCl3. From what we've learned about ionic bonding in the past, we should know then that because chlorine is in group 7, it forms the Cl- ion. If there are two of those ions, Cl- and Cl-, then the charge on our Fe ion must balance those two negatives. So Fe must be 2+ here. That means that we call this compound iron, and then we use Roman numerals to indicate the charge on the metal ion, so it's iron 2 chloride. FeCl3, well, we've got 3 chloride ions, which gives us a total charge of -3. So the ion charge must be Fe3+, so that we get no charge overall. So this compound will be called iron 3 chloride. Voila. So iron 2 and iron 3 chloride. Underneath we have, again, magnesium and phosphorus. Instead of calling it magnesium phosphorus, we call it now magnesium phosphide, because those elements are now combined into other compounds. Now, the three we're left over with, Na2CO3, NaOH, and GaNO3 twice, we notice all contain 3 elements. They contain 3 elements. That indicates that they contain something called a polyatomic ion. Now, you will need to remember these polyatomic ions. There are more of them, but we're just going to limit our list to hydrogen, hydroxide carbonate, hydrogen carbonate, nitrate, phosphate, sulfate, and ammonium ion. Okay, so if we look at Na2CO3, we know that Na refers to sodium, and now we've got another ion, is CO3. CO3 is the 2 minus ion here, which is called carbonate. So our compound is called sodium carbonate. And you'll notice that this ends the word with an ATE. That indicates that not only is there the carbon, but there is also oxygen in that polyatomic ion. Next we have again NaOH. Na again is the sodium. Now we have another peculiar ion, the OH. If we look down here we'll find that we've got OH minus, which is the hydroxide ion. And so we end up with sodium hydroxide being our name of that compound. And finally at the bottom we've got the compound with the metal gallium, and we have a polyatomic ion containing nitrogen and oxygen, and it's an NO3 ion. It's NO3 minus actually over here, and that is called nitrate. So we call our compound gallium nitrate. Okay, I hope that's helped a little bit. In the next episode I'll show you a little bit on how to work out formulas if you're already given the name. Any more problems about this, please ask your teacher. You'll notice also on the blog that there are the solutions to all of the questions now. Thank you.